Probably not.
I wouldn't think so.
That would make it a little easier for de-expedition. Unless you fly on Spirit, then it'll be pretty rough getting there.
Yeah, they have to take helicopters. They take a boat, they have a helicopter.
You have to take a boat that has the helicopter?
Has a helicopter, yeah, because
You can't get close enough to it with a boat?
well, I guess they can, but the depending on how rough the surface is, sometimes the approach by a rowboat is not.
Oh, it didn't even do that.
That's nice.
We're like
19 square miles,
they
93% of which is covered by the glacier.
Oh, crap.
I remember seeing it in QST, there was the expedition, this little piece of coral that's built up, literally, it was like
Right out of the water.
right out of the water, it was like only a couple of square feet. And the guys actually sat there and put it together.
All right, should we get started?
We have a weather station.
Well, that's.
So welcome everyone, this is the November 2025 meeting of the Mid-Atlantic Amateur Radio Club. This will be our last monthly meeting of the year, but we do have the room booked for 2026. So we normally do, we'll go around the room with a round of introductions. I'm Jeremy N2 ZLQ, club president.
I'm Jeff, WA3 RIZ. RIZ. Oh, Ned, WQ3Z.
Bob and 3 JIZ.
Yes, yes.
Jim, W3 JNF.
Lou WX3I.
W3ZQN, Michael and 34MI.
Ron, PC3 Seal.
All right, welcome everyone and welcome everyone joining us online. So let's see, there's no breakfast this month because that was going to be the Saturday after Thanksgiving, so we decided to bag that one. We have no meeting in December, but instead we'll have the holiday party. So Dennis, did you want to give a quick speech?
Saturday, December 13th.
Yes.
I think, 12 o'clock as usual. We only have 15 people signed up at the moment on the second call, but we'll see what happens. I'm gonna call next week sometime, see if we get 25. Supposedly it's never happened, but if we don't get 25, there's like a $100 penalty for use of the room or something like that. So,
What's we're gonna do? We'll just order extra food to go.
yeah, well.
Tell a few people couldn't make it, they wanted to go orders. I mean, it's got $100 worth of food.
10 people off the street have them.
You wait at the bus station.
Well, I can bring my mother.
Just,
Yeah, bring you.
I'm sure I could find something in the brain.
all right. I think of what else we have coming up. We're kind of in our low season. Repeaters, did you want to give
We
a
should definitely have them, really, the activity is like slim and none, but it's not just us, it's a.
I had a pile up on 1-3 last night.
I remember.
What, 2 people?
3.
Small round.
Tell me you.
Did you hear us?
Yeah.
That's it?
Yeah, well, at the home.
In the nursing home from his bed.
Oh, that's, what's his name, John?
John.
Yeah, he's on the ninth floor.
Nice guy. He said, yeah, there's a repeater right on the roof.
That's the,
That's not, that's the worst.
these are repeaters from, Delco areas. Nobody cares. So.
Lou, treasurer's report.
Okay, well, we currently have $19,163.58. And 76 members. Currently. Those paid members.
See, Brian's not here. We did have a VE session back in November. I don't have the numbers for how many people were served by that, but I assume the paperwork is starting to go through now that the government is reopened. I don't know if the dates have been set for 2026 yet, but they'll start up again presumably in February.
I can tell you when the next one
Tuesday, the
is.
first Saturday,
Yeah, the first.
February.
Yeah.
Next one is February 7th.
Is that confirmed with Lower Providence?
I don't think that's been confirmed yet, but
That's just the calendar.
that goes through Brian. So,
Yeah. All right. I think any other business before we get to the election?
Oh, it's a lot.
There's a election game.
Yeah,
the
the email.
email, yeah,
Yeah.
Oh,
yeah.
Yeah, so that's a discussion about the email. We've been using Google Groups for a while, which I think is working pretty well, but are folks having difficulty?
We do have a number of people who have difficulty, and a lot of people, because of the difficulties, have multiple addresses defined to the group, which is shouldn't be necessary, but it is.
Yeah.
So,
Yes, the proposal is to switch over to groups.io, which provides some more features there. It is a paid thing if you go above a certain number of subscribers. I
yeah,
think we're below that right now.
we are below that right now.
Well, it would be nice to have that problem.
Right.
Yes.
Yeah, and the thing is, the free version doesn't have all the features that you get.
It doesn't have files, calendars.
What doesn't happen?
There's a way to store files, so you have a file, tell somebody, hey, download that file. So we get your things like.
Our original Site 5 stuff to do all that.
Yeah, and it does, so, but there's, there's a lot of features, and I know I sent you the full list. I forget what's that.
Yeah, the one reservation I have is if you wanted to email an attachment, does it allow that?
I believe it does.
Well, that's a matter of how you configure.
No, but he's talking about the free version, this free version.
Yeah, I thought the paid one
And I
does,
believe that's the.
How much is the paid version?
$20 a month, that's not a cheap.
$20 a month basically gets us 500. So. And the minimum is $20, it's actually 4 cents a user, but the minimum is $20. So, so basically gets us 500 users.
Yeah, so the consensus will be to switch over to groups.io. I mean, as long as we don't find any issues with it. Maybe you and I could do some testing, maybe over the weekend.
But I mean,
We'll
it's.
try to email
it's
and file.
used by a lot of, like, Montgomery County Areas Races uses it.
RFL uses it, yeah.
My camera club uses
Yeah,
it,
Philmont
we're-
uses it as well.
my camera club uses it, we're sharing pictures all the time.
But you have to pay, right? What's the, okay. Well, I thought there was something about files that it said.
Well, the files. is actually
The file
separate
storage
file-
online.
file storage.
I'm saying, if I wanted to
That's-
email like the Hamfest flyer out to the club as an attachment, I could do that.
Yeah,
Yeah.
you could, even with the free version.
That was the only thing that I was kind of hung up on, if that wasn't possible.
I mean, I'm not sure what the maximum size is, but, but the files, I think, we hope. Probably has a much higher maximum if it even has one.
Yeah. Well, the file's that big, you send a link anyway.
Right,
You don't wanna bombard people with 40 MB attachments.
right. And as Dennis mentioned, the club website has a place you can send files.
Yeah, that's a service provider.
Yeah.
That's what we were using for a long time.
Alright, so maybe we'll figure this
Yeah.
out, but I think that seems to be the way to go, to groups.io.
Convenience is. You log into one, you've got access to all your groups. So
Yeah.
I can log on to
Yeah,
RFL, then I pull down races, and then I can pull down Mark.
well, that's also true of people, but yes.
Yeah,
Yeah, I've got a couple groups on Google as well.
Yeah.
Does that solve the problem of the people that are having problems?
yes,
Okay. That's,
I believe.
well,
Yeah.
if it's
Can
not
I
gonna solve the
guarantee that?
problem,
Yeah, I mean, it does solve the problem, and the last time somebody complained, I actually tried to do some testing and I couldn't even get Google to. To respond to some of my test things that I was trying to send them, so I got frustrated and said, we gotta do something better.
Well, how much you're paying for Google?
It's free.
You get what you pay for.
Rob,
Yeah.
you said you get.
Well, you gotta be careful, we're on Google right now.
there's a chance.
We're getting on the
AI is watching.
Yeah. Alright, I think that's the way to, I mean, one of the errors that people were dealing with is if you have multiple email addresses and you try to send from the email address that's not subscribed. It doesn't know who you are and it rejects the message. That will, I think we'll have a problem no matter which service we're with.
Right.
Right,
I mean, you could certainly open it up and let anybody send, but you don't want, generally, you don't want to do that.
Yeah, cause then, you get random,
Right, yeah.
spam and crap,
Right.
yeah.
yes.
Alright, that seems to be the way to go. Any other club business before the election? Brian. You wanna talk about VE testing?
We conducted a session. And one guy showed up and he passed. For the. Package electronically to ARRL. I guess which we, issue back in business now.
I guess, the processing must have been delayed because of the shutdown, but. I imagine it should have gone through now.
Yeah,
Yeah, they had it all stacked ready to go. I called to make sure.
Okay.
For the new year, we're gonna be having some expenses of Darby and the 60.
Okay.
The situation there is very strange. We have the Darby 2-meter repeater, 147.36, non-responsive, so. Truck up there after a couple of weeks went by. And I could key it up for the parking lot, which is never a good sign. Nowhere along ways on that, you nothing, but parking lot, no problem, under the end. Well, did a quick test, Steve, K3 FZT. And the 24-foot superstation massive antenna on top of the 50-foot tower on top of the 11-story building. And everything was reflected.
Everything is what?
Everything's reflected. So there is a polyphaser in line, but it was like welded shut because it's been there for about 4 years. So the next trip is WD-40, a couple of big wrenches, and that out. We already bought a polyphaser a couple of months ago. We'll put that in, cross our fingers, maybe it comes back on. If it doesn't, then the game plan is to put a sidearm and just a very simple G7 or something like that, do a high gain vertical or something, just get that up here. See how that goes.
Is there a direction with more deployment? Is on the
The
side?
direction I can climb up the tower.
You're gonna climb the tower
Don't tell my wife, please.
or anyone?
So back to the VE, the next VE session is February.
Yep.
Have you been in communications with the tech, or Providence Township to make sure that. Cause I mean, basically, renew that every year, I believe.
I think you told me what to do. But I will check.
Okay, very,
And normally there's a couple of forms we have to do too for insurance.
right, there's a couple of forms and they always
Waiver.
want a security deposit kind of thing.
Yeah.
I do the week to week. Session
Okay,
coordination,
okay,
but I thought we had the play schedule through 26.
yeah, well, February is 26. You're saying for the end?
Yeah.
26, cause I didn't pay any more for security deposit than I did
Okay.
last year.
Let me double check.
We do get that back, but.
Yeah.
Well, just
Well,
what?
I mean,
Well,
well, you see, that's the trick with checks. Technically, checks expire.
Oh, yeah.
I'll say they're deposit in escrow.
Right,
okay.
no, they don't, they just keep the check and.
Oh.
I'm good for.
Yeah.
So if we trash the room, they couldn't get
Yeah,
money.
not like Kimberton. Kimberton did deposit the check and they did finally mail the check. They.
Okay, we got that.
No, we did get it, but it took a while.
Yeah, when we do that,
They started.
that's true different, we do that, yeah.
On the topic of Kimberton, Bob, did you have any updates for Hamfest?
No, we still have a tentative date of Sunday, August the 9th for our 2026 Hamfest. Setup date is Saturday, August 8th. The Kimberton unfortunately hasn't gotten back to me yet. That's still.
Okay.
Out now. I'll give him another.
The Hamfest is getting great reviews every time I run into something.
Yeah. Always.
Yeah, it's one of the highlights of the club.
It is.
All
What
right,
was that date, Bob? 9th?
Sunday, August 9th.
Yeah. And what did you say about the 8th?
That's the setup day, Saturday.
Oh, it's set up, okay. Okay.
Jim, do you have the election results?
I certainly.
It's
do.
real nail biters here.
Yeah.
Yeah.
See who got in.
Do you want a drum roll or anything?
No, I'm good.
Let's wait for the Associated Press to see if there's any recounts, any legal challenges.
Anything like that. Did everybody vote that wants to vote? Cause I have ballots, you can vote up until the 2nd, so.
But
Okay.
didn't the bylaws say how much percentage of the club membership has to vote?
No.
I hope not, because we would be in trouble.
Yeah.
The results were, I received 12 ballots back. They were all everybody voted for the same people, so. It was a little different.
No, that's
One for here, one for here, one for here. Anyway, the amendment, that's only, that's less than 50%. So it's not a whole lot of people voting. And the results were Jeremy president, I was vice president, Brian secretary, Lou treasurer, Member at large Michael Mitchell, technical services Dennis. Public service Jim Foster, programs chairman Jeremy Carlo. And we have 2 vacant spots, if anybody wants to consider that in the future, so. Very good.
They were working.
Yeah, because you had some interest in it. I was surprised you didn't write yourself in. Public relations and member services. I think you were interested in member services.
It was something I thought.
I make a motion, we appoint, I already said member services. Say aye.
What is
Put it on
it?
the board meeting.
What is it?
We got a board meeting in 2 weeks.
Yeah, talk to people and get members. Yeah, we'll do that. We'll put you.
I don't want to go to any board meeting.
Why not?
I don't want any board meetings.
It's only 4 per year. And it's on Zoom.
Oh, they're on Zoom, all right.
Yeah.
Well, let me ask a question. Are we going to, sometimes we have a board meeting at the bar at the holiday party.
I think it's better to do it maybe the week before.
Okay, good. Okay.
Yeah, actually, when's that gonna be? It's like.
Yeah, we stopped doing that because,
You got a little rush.
yeah,
Yeah,
Because people.
Well, that's because
turn away.
people came early, so. Okay.
yeah, so we'll probably do it the Tuesday night before.
Well, frankly, there's my office is across the street. And if we weren't locked down like Fort Knox, I could get you a conference room, but. You know, like, it's.
Yeah, Zoom's fun,
Yeah,
so,
that saved us a trip.
yes, especially on a night like this. All right, thank you very much, guys.
Thank you for the reference. And everyone around.
did think of another thing.
Yeah.
I mean, for Skyward, I've been contacted, I don't have an exact date yet, but I've been contacted by a club that wants to do a Zoom session, Skyward. Not my favorite way to do Skyward because, you know, the interaction with the audience is different, but as soon as I get that date, I'll let everybody know, and I've also been reminded that Montgomery County Areas Racing has started up a Skyward. Right now, they're doing it once a month, just, you know, it's basically a breakfast night. And then it's Tuesday nights.
It's Tuesday, yeah.
Yeah, I forget what Tuesday.
Well, it was, would have been, the night of the drill, so whatever that is.
Yeah.
Saying next week.
Yeah, I think it's second Tuesday,
Could be.
seven P M,
Yeah,
and it's on Montgomery County Areas Racing's 2-meter repeater, which is 146.835.
Okay.
The PL of 88.
That's the one with all the interference.
That's it?
That's the one with the interference on it.
Yeah.
Yes. That's on
My alarm went off, I didn't even mention because we were doing something.
And the,
My alarm
right,
for the weather pad, is it?
right now it's being, mostly run by Bill Mangan. That's his name.
Yeah.
Yeah.
He's gone from like who to.
Yeah.
All over the place.
Yeah.
He's
He was here for our,
Oh, yeah, he
our
gave
mesh network stuff.
Yeah,
Yeah.
that really set him off.
Yeah.
He really, yeah.
Yeah, so, and he's doing the Skyward Network, and he's Skyward Net, and then he's doing a bunch of other stuff to support the Skyward Net. You know, he's a teacher at Ursinus, doesn't have anything else to do, I guess.
Well, it all fits into his.
Our teachers haven't used the PA.
It all fits into his.
Brian, right, something else?
Yeah, the November breakfast, eyeball still on count.
Was it still on the
Oh,
calendar?
is you have to
Refresh.
refresh, you're actually getting out of your cache. I took it off.
Ah, okay. Could be.
All right, so if you have no other club business, we'll go to our main presentation for tonight. So we have a man who needs no introduction. Here he is, Dennis, K3DS, and he's gonna tell us about near vertical incident skywave radio propagation.
It's the push ahead button.
Yeah, let me share screen. Here.
What's the little circle with the arrow? And the square.
All will be explained.
Okay.
Circular poles,
Gotta resume slideshow.
That was when you steal pictures off the air.
Yeah, well.
There you go. Push ahead button, the big thing.
Left and right. The middle is the laser pointer.
Okay. All right, so the topic of tonight is called near vertical incident skywave radio propagation. I'll remind you that In September, I did the standard HF long distance skyway propagation, that we discussed, and we came up with some ways to look at it. This is kind of a very specialized technique, but it's not something you really can't do, especially for a very, very focused application. So first of all, what is near vertical incidence skywave? NVIS is a special case of HF skywave propagation that enables both skip zone coverage as well as coverage in challenging terrain where ground wave or low angle skywave signals might be blocked. So for example, if you got a bad terrain like this and you want to communicate with somebody over the hill, a little bit hard to do. Whereas if you have a skywave system where you basically are going to do what we're going to do, which is a very, very sharp takeoff angle up to the ionosphere and basically get it reflected directly down to give you a sort of a local response in challenging terrain. So the key here is really 2 or 3 things that we're going to see, which are important in order to make it work. NVIS is implemented using an antenna with a very high takeoff angle, typically 75 degrees. This is not the kind of takeoff angle that we normally do when we want to do skywave propagation or DX or something like that. Transmissions will also take place on the lower HF frequencies. So this is not 20 meters, it's not 15 meters, it's basically 80, 40, and 80, 60, and 40 at the most, what we'll see. And we want to make sure that we pick the right frequency so that when they propagate to the ionosphere, they in fact get refracted. I want to remind you in September's discussion, I told you that the ionosphere does not reflect radio waves. It in fact refracts them. So we want to be correct when we talk to people in the air. Okay. So this local or regional coverage makes NVIS very well suited for applications that require communications in challenging terrain, as we said. And for example, during disaster relief operation, where you just want to be able to cover a local area well without worrying about the propagation and things like that. However, for normal QSOs, NVIS allows good communication to local or regional stations where propagation from conventional antennas would be blocked by terrain or would be in the skip zone. So normally when you have a low angle of incidence in your antennas for skywave propagation, you basically will skip over an area. And that's that frustrating thing where you can't talk to anybody in the middle because that's the way the propagation is going. It's basically not going to be refracted in the area that you really want to talk. Okay. So NVIS has several technical advantages. The first of these is that the NVIS is more resistant to fading. And if you've operated HF, you know that you basically are at the whims of QSP and things like that basically happen. And skywave propagation, in fact, will be less likely to have fading propagation. The near vertical incident angle of an NVIS antenna means also shorter path through the ionosphere and therefore less absorption. So basically it just goes up and comes back down again. Instead, it's not really designed for long distance DX communication. So the overall length is much shorter and therefore not as much absorption. Signals are stronger. Okay. So remind you what the incident angle is. The incident angle is the angle at which the signal reaches the ionosphere. Okay, so it comes up in some manner. And these are kind of nice descriptions because it does not show a reflection, it shows a refraction, in fact. Waves don't exactly reflect, they reflect off the ionosphere. So the incident angle plays an important role in determining how far a medium frequency, high frequency radio wave skywave signal will propagate. So here we obviously have that idea for long distance DX communication, at least on the first hop. Okay, so for NVIS, the shorter overall path length reduces the attenuation between the transmitter and receiver because it's not going as far. It's basically just going up and down within the local environment. Attenuation of the signal due to terrain or obstructions is minimal because there is a line of sight propagation between the transmitter and the ionosphere. You don't have any mountains on top of you. So basically going straight up and then basically straight back down again. So it's not like there are other obstructions in the way like we would normally do with low incident angle skywave applications. Okay, so that's that. Let's see. Well, this line of sight propagation also helps to reduce fading due to multipath because a near vertical takeoff angle reduces the opportunity for the signals to be reflected from obstacles. Multipath is when you happen to have things like buildings in the local environment and signals are bouncing off them, And you get these interference patterns because the signals coming actually may be constructive or destructive, so that's what multipath might do. But in this case, we're just going straight up and straight back down again. There's no buildings above us or anything like that. The combination of these factors means that MVIS works well at relatively low transmit power levels. So you don't need a kilowatt to actually have reliable communication in the local environment. Okay. The roughly omnidirectional coverage pattern, as we're going to see, we'll take a look at some antenna patterns of an NVIS antenna, makes the antenna orientation or azimuth less critical in providing coverage to desired locations and facilitates operations such as local and regional HF nets. So you have a dipole, a transitional dipole, several relatively high above the ground, has a sort of an egg-shaped pattern. I'll show you an antenna pattern coming up, which means that you're going to get propagation off the broad sides of the antennas. That's your best propagation. Very little off the ends. Well, NVIS will get rid of that particular problem, as we're going to see. There are, however, nothing comes without problems. There are also some disadvantages when using NVIS. One of the most important of these is that NVIS only works at lower HF frequencies, usually below 20 meters. So basically, and the reason for that is the characteristics of the ionosphere. So the nature of an NVIS antenna pattern and propagation limits the maximum range to low hundreds of miles, obviously, because it's going to go basically straight up and basically straight down again, covering a local area, compared to the thousands of miles that we normally get with low angle incident skywave propagation. So it's really designed for local coverage. And it's very good if you want to have like a local net or something like that on HF. It works a lot better to do it this way than it would be under conventional characteristics. Okay. Optimum results require the use of an NVS antenna on both the transmit and the receive to work. Obviously, if the fellow you're trying to talk to has a conventional dipole antenna, he's going to have orientation problems. We'll be able to get into the net and stuff like that. If you want to hear this in operation, tune on 80 meters, a 75-meter phone at some time. A variety of local nets are on NVIS because everybody's all over the place, so you don't have to worry about the directions and things like that. And they cover a couple of 100 miles around, no problem at all. Everybody chats really nicely.
So I'm not gonna use my 80-meter beam for this.
Not for this.
Oh, could you point it up?
Yeah, you probably could, but it would be a waste of aluminum for sure. An additional potential disadvantage of using NVIS is that the both atmospheric and man-made noise levels tend to be much higher. We all know that 80 meters really suffers from noise, and you're going to be operating right in the middle of either naturally or man-made noise level, if you will, essentially on those bands. Okay. To make effective use of NVIS, we have to go back and talk about the ionosphere and the different characteristics of it. Frequencies that are low enough to be refracted, not reflected, by the F layer of the ionosphere. The F layer is the highest layer, as it turns out, when arriving at a very high incident angle are used. Okay. During daylight hours, the F layer splits into two sublayers, at least according to theory and also practice. That's just a fact. Called the F1 and the F2 layers, which then actually merge back together again in a single layer at night, and the characteristics change as a result. The lower F1 layer primarily supports communication during daylight hours, and what they mean is normal skywave DX type communication. The F2 layer, on the other hand, is present more or less around the clock. So basically, we're going to be using that for NVIS, middle of the day, no problem at all. The F2 layer has the highest altitude, and of course, that's not a fixed number, it's a variable number, but it's one that's recognized to be the highest altitude and the highest ionization of all the layers, and is therefore responsible for the vast majority of long distance HF radio wave. You can if you recall September's discussion, we do use the F layer with the low angle of insight. You just happen to hit it at a low angle, and basically it bounces farther, and that's how we get DX. So we are using the F layer for communication, but in this case, we're going to be using it by going straight up and coming straight back down again. Okay, so here's what we mean by how the ionosphere refracts. Before I talk about the frequency ranges, here's some examples of signals basically going up, being refracted by the highest layers of the ionosphere and getting longer and longer path, depending upon the incident angle of how the antenna is actually firing. Oh, And also the characteristics over time of how the layers are actually moving. But that's typical for DX communication. So NDIS also has to avoid this problem. If you operate with too high a frequency with an NDIS antenna, too bad, it's gonna go right through the ionosphere, just keep right on going, essentially. So that's why we're gonna take a look at that as a requirement. So if the signals with too high of a frequency will simply pass through the F layer and into space and will not be reflected back. Okay, NVIS also requires the use of frequencies that are high enough to avoid excessive delay layer attenuation. The reason why we can't use high frequencies includes the fact that the D layer actually attenuates them, if you will. So we want to try to pick a happy medium between the two. Okay, the D layer, the lowest layer there, exists only during daytime hours and disappears at night. Although the D layer is ionized by solar radiation, the density of free electrons in the D layer is too low to refract radio waves. But basically, it's still a conductive element of the ionosphere. The D layer inhibits communication because it acts as an absorber, unfortunately, as opposed to refractor, if you will. In order to balance these two somewhat conflicting requirements, NVIS operation uses frequency in the range of approximately, say, 2 to 10 megahertz. 80, and in case of amateur radio, 80, 60, and 40 meter bands, if you will. Possibly 20, but not very often, quite honestly.
What about 30 meters? That'll be at the upper end
Well,
for digital.
yeah, I sort of discounted that because most people are using sine, if you will. Yeah. It's bad enough talking about 60 meters with the channelization. You're right. Okay, well, 30 meters would be the next one. The 40. Okay, however, like all other skywave propagation, the maximum frequency depends on the level of atmospheric ionization. This in turn depends upon factors such as sunspot number, solar flux index, the time of the day, the season, and any other abnormal solar event. So basically, the characteristics of the ionosphere are not fixed, but we're still going to use the characteristics of the different layers and how the ionization works through NVIS. Okay, so that's the background, at least as far as the ionosphere is concerned. So during solar minimum, the maximum usable frequency seems to be about only 6 to 8 megahertz. So you go too low, you get too much absorption, like on 80 meters or something like that. So you have to pick up. About 40 meters is one of the most popular frequency for NVIS use. NVIS usually uses 80 meters during the day and 80, 60, and 40 meters at night. But this can also vary significantly, but usually 40 seems to be the happy medium between the two requirements. Okay, most antennas required for HF skywave communication are designed to have a low takeoff angle or radiation angle. We're trying to do that because we really want to talk to DX stations and not people in the immediate vicinity. This lower takeoff angle causes a lower angle of incident with the ionosphere, like this, and hence longer distances due to lower refraction angle. So basically, you come in with a low incident, you hit the ionosphere eventually down the line. But remember that when you're doing that, you also have obstructions with that lower angle of incident could hit a mountain if you're not in a totally flat area and things like that. So there are also trade-offs even there. So ionospheric refraction is the bending of the propagating wave. So we're all going to go at least out from now on and always talk about refractions from the ionosphere as opposed to reflections. And this is a slide from September's talk, but recall that the ionosphere does not reflect medium frequency, high frequency radio waves, but in fact refracts them. The definition of reflection occurs when a propagating wave, for example, interacts with a conducting surface. So a good example of that is a parabolic dish. So basically, that is a true reflection. When it comes in, it's basically reflected away. Okay. In traditional long distance application of HF skywave, an antenna that sends too much energy vertically is sometimes unflatteringly referred to as On the other hand, NVIS antennas are specifically designed and installed to have a high radiation angle, typically 75 degrees or higher. The majority of RF power then is going up instead of going out. So that's the takeaway from this. One of the best ways to understand the difference between traditional low incident angle skywave antennas and NVIS antennas is to compare antenna patterns. Since NVIS can be implemented as a dipole, we'll start with that as the simplest example. And we can compare the characteristics of a standard HF dipole design for skywave HF EX propagation and an NVIS dipole, if you will. It's the same physical antenna, it's just a question of where you mount them. Okay, so a standard HF dipole is usually mounted at a height that produces a relatively low elevation angle. So you want to try to have a low elevation angle in order to get DX activity out of your dipole. Remember, of course, the dipole is highly directive also. The relationship between elevation angle and the antenna height is somewhat complex. The complexity has to do with the characteristics of the soil underneath the antenna and things like that. But generally speaking, the higher a dipole is mounted above the ground, the lower its angle of takeoff is. So that's why when you see these big contest stations, as Jeremy says, with the 80-meter beams on them, they're also on 100-foot towers, right? In order to get them really up in the air with a low angle of incidence of takeoff. So that's essential. This is we'll talk more about this, but this is a theoretical antenna pattern of what a dipole would look like cutting through the response. So generally, that's how we can plot these things. So it says that the antenna has the best response at that particular angle. That's the fattest part of it, if you will, but it's also bidirectional. Let's see some other ones. A lower elevation angle works well for long distance HF to skywave because greater distances can be achieved when the transmit signal is incident to the ionosphere at lower angles. So basically, that's how we get. Of course, this over here is all blank area, skip zone, but we do get propagation further and further out. Okay. Now, an NVIS dipole, this is physically the same antenna, it's still a dipole, is characterized by a much higher or more vertical elevation pattern. The primary method of creating this type of vertical radiation pattern is by moving the dipole closer to the ground. Okay, that will essentially cause the pattern to raise. So if we move an antenna close to the ground, if the ground is reasonable material, not say desert sand or something like that, then this is what would happen to the incident angle, because much higher as a result. Okay, that's still the same physical dipole, but it now has characteristics of the incident angle being much higher. So we can put them side by side and you get the point. And these are, of course, called elevation patterns. They show the distribution of energy or gain in the vertical plane around the antenna. Like we sort of take a slice through it and we take a look at it. The elevation pattern comparison of a standard HF dipole and NVIS antenna demonstrates the differences, and that's the key element here, is that the incident angle is much higher as a result.
Question, sure. Is there kind of a rule of thumb about how low you should keep the antenna for invis?
Well, they'll give you some typical design examples, but obviously if you move the antenna, say 2 inches off the ground, then it's going to get it'll be a very good NVIS antenna, but also be absorbing by whatever's underneath it. So there is a happy medium.
Yeah, pick up the earth warmer.
Yeah, then it becomes a ground wind. Hey, it's good for your driveway then.
Yeah, worry about plowing your driveway.
Yeah, maybe you get the earthworms to go up if you're gonna go fish tonight.
Yeah. All right, so take that away. That's the elevation pattern, which is a vertical. The incident angle is clearly indicated here. But here's a really interesting one. If we look at it this way, this is the azimuth pattern. This is how the antenna works in sort of this angle, right? The azimuth, if you will, as opposed to the elevation. So a standard dipole sitting here at the origin has this sort of donut shape, approximately. But obviously it's bidirectional and it's the incident angle is low as a result too, but it's also highly orientation oriented wise. The interesting thing is the same dipole, which we think would have this sort of preferred direction broadside off the antenna. If you bring it lower, then the same dipole has almost an omnidirectional pattern, not quite, but very close to it. So a standard HF dipole has a directional pattern with the majority of gain being broadside to the antenna. So when your wife says, I don't want that thing hanging over the backyard, you have to say, no, I need that in order to go to your gym or whatever. But in this case, the NVIS antenna is much, it has almost no preferred direction. If you look carefully, there's a little bit of change from one end to the other, but not much. Whereas over here, off the ends of the dipole, you get very little gain, as it turns out. Okay. Right. So in a typical NVIS antenna, the azimuth pattern is roughly omnidirectional, meaning that the orientation of the NVIS antenna is less important. So if you want to work local stations here, there, and everywhere, that will give you your omnidirectional pattern, at least under the constraints that we've been talking about, lower total distance, for example. Okay. Now, NVIS describes a certain type of antenna, or more precisely, a certain radiation pattern, an elevation angle produced by the antenna. However, there are many different types of antennas that can be used, and I think Jeff is going to talk to us about that at the end. Nice follow through. There are, however, many different types of antennas can be used or adapted to produce a high incident angle antenna pattern. I'll show you the one that I have in the woods behind my house, as it turns out. Some of the most frequently used types of NVS antennas are dipoles that we're familiar with, and also inverted V antennas. Maybe not the way you're familiar with it, but an inverted V antenna. Basically, just bringing the ends down, if you will. Okay. So one way to build it is to do this. And as far as the heights above the ground, they usually say about 2/10 of a wavelength. So pick a number, 80 meters, 2/10 of that. A standard halfway dipole can be used for NVIS applications. In order to create a more vertical radiation pattern, dipole needs to be much lower, usually approximately 2/10 of a wavelength above the ground, just as a rule of thumb. Generally speaking, the lower the active element, the higher the radiation angle, but as Brian pointed out, if it's too low, then it just heats the ground up, obviously, so there's a happy medium between the two.
Now, even a normal antenna on 80 isn't much higher than that.
That's
16 meters,
that might be
50 feet.
why we don't get very much VX, if you will.
Yeah.
That's absolutely right, yeah. Let's see, I'm running inverted V's to tower on 80. I think the incident angle is just a little bit higher, as it turns out, because the feed point's up at 40 feet here, a little better than head feet or something like that. Okay.
Your 0.2 wavelengths to 80 meters is 16 meters, which is 50 feet.
80 meters is 240 feet roughly, right? So 30 foot in the
So a
year.
fifth of that is 50 feet.
That's 20 feet, but I think it would
Most
be,
people can't get higher than that.
it would be even lower.
Never.
I mean, yeah, my tower's only 40, so that's a bird of phase. So I've been running NVIS all this time.
Yeah.
Okay. But anyway, characteristically, they talk about as relatively low antennas, if you will. To some extent, the optimum antenna height is also a function of ground conductivity. The higher the ground conductivity, the lower the optimal height, as it turns out. Well, we don't know ahead of time how good the ground is. All of this is based upon flat theoretical calculations and not, sides of hill or something like that. Because of this, the use of an optional reflector element has sometimes been recommended, for example, especially when the soil has a very low conductivity, such as sand or rock, which is my backyard, which is rock, or if the dipole is high above the ground. So basically putting in a reflector is the way they show it in some constructions, another wire down there. That's not a driven element, that's essentially a reflector element. So it's like almost building a vertical beam, if you will, as a result. But this is what I have in my backyard. My grandson calls this the maypole. Just dance around if you want. An inverted V is a variety of a horizontal dipole, with the center of the dipole being supported by a vertical mass and the end very close to the ground. Very common implementation of the inverted V is two dipoles positioned at roughly right angles to each other, like in a maypole configuration. So this arrangement is sometimes referred to as a turnstile antenna. It's relatively easy to put up, just a single pole and a couple of wires, and you're good to go. Using a pair of dipoles also helps overcome polarization and any residual polarization and related fading that you would get out of a turnstile type antenna like this, or just an inverted V for that. Okay, so NVIS antennas, in summing up, are on 80 and 40 meters, facilitate local and regional rack juice. So basically, if you want to get in, and like that happens to be on my real ARL rack chore certificate circa 1965. That's okay. I dug it out of the archives, if you will. I don't think they give those. They don't look like that anymore.
Do they still have that club?
I think they still have it on the website.
Yeah.
And when we did this back in the day, you had to like send in all the different QSOs that you have, like right out of your logbook, but now they just believe you just send it in, they'll send you by email, you have a registered certificate of it. But it used to be a very, very formal thing, right, so many hours of talking and all that.
You still have to crow for the rooster.
No, you don't have to cry.
You don't have to crow for the rooster
I've
thing?
never done that, I don't plan to, so.
And we're gonna report that, your membership will be revoked.
Yeah. So here are some local clubs that happen to have local nets, if you want to give them a try sometime. Philmont has one. There are a couple that come out of the EPA league, if you will. And also sort of much more regional ones. I don't know how up to date these are. These are generated by asking Google AI.
Pretty close.
Google AI for some NDIS type of, just a local nets on 80 and 40 meters is what I asked. So they're free for interested in
Well,
that.
all of the racing nets are the high end of 80 in the morning and Sunday.
So you can give this a try if you want,
And
or whatever. All right, so that's it, basically a short discussion, basically that's what NDIS is all about, now you know.
On the turnstile antenna, could you have like an 80 and a 40, you know, instead of
Yeah, you could put
all
loading
like
coils, yeah.
dual band?
Yeah, make it a dual band inverted V with 4 wires like that. I have 40 meter one, just cut straightforward, no loading coils, save money.
So are you using both at the same time, or are you doing like an A/B switch between the two?
No, they're all wired, there's a tori that links them together.
So you're loading up both at once.
Yeah. Yeah, there's a, so they show this in the artist conception, but there's a big two radial transformer that links the two antennas together, bases. There's
why do you do that?
what's that?
Why is that necessary?
I'm trying to bring the two antennas together, if you will.
As
I have
one?
two- Yeah, as far as, there's a feed line, you can check it out in the URL antenna book. I've got a couple of different versions of it, URL antenna book.
Yeah.
There's one feed line that comes in here, and then there's a torial transformer that phases it properly, so you don't get cancellations and things like that. Anyway, ARL antenna book will have that description. And there's a couple of people that actually sell those toroids and all, so just so I'm sure. Okay. But does that answer your question, Mom? Okay. All right, well, that's it. I think I'm gonna say antennas. That's probably what.
You keep that as.
Show it out.
Yeah, it's just showing the
It's
test.
your turn.
So this is my attempt to play with them, but the only back on here, messing around with it, I've done this with Red Cross. Red Cross? Yeah, Red Cross Net. I think it's the second Thursday of every month. And the first time I did it with a 40 meter dipole. And I started out with putting that 40 meter dipole between 3 sets of these stacked streets, so 12 feet off the ground. And I have a center feed point here with a lip, and this is a little wiper holder, so I can just loop it across the top of the pipe. So I put three sets of 3, and I have a friend, he has a 3D printer who likes to print things. And so he built me some guy wires so I can stick these posts up. And I keep I have 10 stakes, much bigger than needed. But I also use a landscaping spike to go in ground underneath and keep from kicking out. So that's what I did with the 40 meter dipole the first time I did it with Red Cross. And we had guys, you know, like all over the Delaware Valley, Delaware County, across the river in New Jersey, everybody just huge signals. We were just close and the noise you know, you say it picks up more noise. Yeah, everybody reports more noise, but you know, they're getting through with good strong signals. So that's that. And then in the process of waiting for this to come in the mail, UPS or United States Postal Service has a habit of losing round long things. They fall off the machine, and then apparently people just throw them back on the table. And so this thing went from Scranton to Philadelphia, to Harrisburg, Philadelphia, to someplace up in North Jersey and back. I was expecting it to go to Delaware the next time around. So it's 3 weeks to here from Scranton. Anyway, so this is a collapsible one. It goes to 13 feet, and I think it's actually, I believe this is what the military uses for their version of the thing. And that's what there's a, I can't remember the name of it, but there's a military version that is these inverted V, and it does use effectively whatever they would use for 40 meters of medium. And then DX Engineering sells one to keep the relative length of the 80-meter side of it all the same, so the 80 because if you try to do a fan dipole with an 80 and a 40, the 80 is much bigger, so it gets a little bit more complicated. And so what DX Engineering Solutions has been is to give you a coiled version. It's a lot more money. It's like, I didn't pay that much for this, I didn't pay 50 for this. I was searching around on eBay, I had watched for poles, military poles on eBay. I saw this one, it was like, yeah, 24 for $40. Come get it. So it was a warehouse in northeast Philadelphia. At one point was a rescue of dogs, greyhound rescue. Anyway, so in my efforts to try to get these things to install as quickly as I can, if I go out, I just don't want to be able to get it up fast. I don't want to be screwing around tying knots and so on. I get these little ratchets, and they fit nicely into these.
Maybe we should try this out field then.
Yeah.
Well, yeah, I would very much like to do that. And like I say, these are nice little ratchets that help it simplify the install of this one. These ones, I just got tensioners. And like I said, again, I just want to go out, stick the stake in the ground, put a spike in. This is short enough that I can then tie with the center of the dipole in the middle, and then put it up, and then just go out. So I don't need to, I really don't need to worry about ends, because you just take it out far enough that it's sort of level. And then but I do usually would want to use at least 2 of these just to get it above choking distance. Because if you build it, they will come. Everyone's like, oh, what are you doing? Oh, I'm building the antenna, watch yourself. So yeah, that's good. It's a feeling that I should have, don't choke people. And the other thing I discovered, I went up and set this up at the PAQSO party with Philmont, and they set up in Fort Washington. It turns out Pennsylvania is very rocky. Like, how do you get these damn things in the ground? And so that was a bigger hammer. Yeah, well, even a bigger hammer didn't help. And but what there was enough trees around that I could strap them around the thing, but I needed all this damn power paracord to get around the trees. So next time I got a strap, run a strap around the tree. I don't damage my paracord. I don't damage the tree, and I can see where I put it. And so, as far as I can reach, I can wrap this thing around and then run my paracord through it. So, just some things that I've discovered in a little bit of playing around with it that I've done. And then, so this is my center feed lift. Because when I do that, it's 12 feet and it's a little harder to reach. So I just run this through this little pulley that I tie at the top, and that little clip clips through. Another 3D printed favorite of mine from a friend, one of the first 3D prints I did to be a dipole center. And so I made it so that clips through too and pulls right up. Which is pretty cool. And he hasn't seen it in operation yet. He says when you tell people about it, make sure you quote a good price. Because he wants to make more. What else? Oh, so this is kind of hard to lift up and show. But this is a 80-60-40 fan dipole. And so that's what I place at the top of 3 of these. And then I go out and again, with two 3-foot sections, or, yeah, 3 sections at either end. But again, the 40 is so much shorter than 80 and 60 that I've gotten to the point where I'm just gonna go ahead and put another set of poles up, probably at 2 of them each rather than 3. So that it'll fan out nicely. So the only thing I have left to do, I've used this a little bit, I think on 80. But you know, you start building fan dipoles, getting the SWR right, it's a little tricky, so you know, one impacts the other and so on, so I still need to play around.
What did you find when you had to load it up? I mean, what kind of bismarck were you getting? Were you tuned? Put a tune on.
Well, I don't put a tuner on.
I put a tune on, it doesn't seem to resonate.
Yeah. Right. Yeah, I mean, I cut the 80 for 30.9 and the 60 for just the first channel. Which seems to be the only one anybody uses, if they use it. And
50 or whatever the lowest one is.
yeah, whatever the lowest one is, yeah. And then the 60 and 40 is 72.35 because that's where the Red Cross parks. They do that regularly, so that's I've been just playing around with the hardest part for me is getting out to the park because I don't have enough room to put this up at home. And I have a hard enough time getting out of the house as it is, without going over to Hoyst Park for 3 hours to set up an antenna, operate 2 stations to tear it down. But I'll get there. I'll get there. I have every confidence that I get there. And then this is what I was talking about with setting up when we were at the firehouse. And we had talked. I had heard there had been conversations in the LGS planning was whether or not they wanted to do communications back to Harrisburg. And unfortunately for me, they said no, but I would have liked it. They said yes, because I would have been ready. Would have been totally ready to go. And that's my whole idea. It's like and with EMCOM, you know, and the playing around with the narrow NBEMS messaging. Got it. I had it working on 2 meters 440. And they apparently are also using it on HF, and so there are NBEMS tests on HF as well. Well, I know how much trouble you had with that, setting that up, and I have one working. Well,
Did you find out that the next after the drill worked perfectly?
No, I thought it quite the opposite.
But after, you know, the trouble I had before the drill.
Mhm.
Worked perfectly.
Mhm.
I fired it up Thursday night for the net. Didn't work.
Yeah.
And I haven't really played.
Yeah, I could receive Thursday night, but I still haven't been able to test the transmitting, but at the moment, I can no longer key the transmitter with it. So, you know, I can see the crap text going across where it just sits there and decodes everything. But then, you know how, well, anyway, it is really finicky with the radio and the
Ring cluster.
Windows. Yeah, no, well, I
I
use
think
it
the problem is the Windows, my computer updated,
Oh, yeah. And then the problem I ran into is that the radio has this little 10-pin DIMM on the back of it.
Yeah.
The VHF, UHF radio. And you know, you can plug it in, you can get it in there, and you know, you can do the thing where you go and find out what the COM port is. And then you go and you make sure the USB cards are up and running, right? That they're visible on the computer, so it talks back and forth. That still doesn't work. And then
You might wanna try lowering your RF gain. Because if your signal is too low, too high, it's gonna be distorted.
oh yeah,
Even on ST8, you know, that little bar that comes up and goes red, make sure it stays red.
they stay down, yeah. In fact, there's one setting, Steve talked me through it on the net. And to take it down further, it was like out of 0 to 50, it was like 4.
Yeah.
You know, it was
It doesn't
really
take much.
Yeah, it doesn't take much at all to drive it, so that was pretty cool. But the hard part is finding somebody to test it with.
Yeah.
If you hear me calling you.
Yeah, well,
I
I
got
don't-
MBS and we'll get it working.
I can't promise anything at this point.
Yeah, I think I got in trouble when I took it off the rig. Well, first of all, I couldn't transmit during the drill, but I got home and I found one of the plugs in the digi-rig had sort of pulled out from my screwing around with it behind the radio, not being able to see. Then I hooked up the wires X cable, which means unplugging and plugging in wires X cable. The wires X cable has a different RS-232 driver, comes up on a different COM ports. And now you've lost everything that you've done for NBMS, and now now it's like, okay, great, I got wires X working, but then I take wires X out and I can't use the digi-rig anymore. So I figured maybe I can help this problem. Went out and bought a 10-pin pass-through DIN about that long, so I could get around, plug it into the radio one time and plug it in and out of this cable. None of them work there at all. None of them. All three. When I say three, the third one is the programming software. RT Systems would not work for that through that big test. Well, that's a whole nother ball. It's nothing to do with NBIS, but this is a lot of fun if you want to play. You just can
What are those poles made out of, Jeff?
Fiberglass.
They're all fiberglass?
Yeah,
Okay.
yeah. Fiberglass, they're military surplus. You get them all over the place. And I would say they're a dime a dozen. But to find them for a dime a dozen, you gotta look, because a lot of guys are really charging. I mean, for what I paid for 24 of these. And like I said, it was a dog one. I'm like, what did you guys use them for? And they're like, well, we use them to hold up the judging platforms. Okay, that's cool. But we don't do that anymore, so you're gonna have them. And I swear, when I told the lady, here's your money, she's like, oh, they charged you?
She thought you were paying.
Yeah, she didn't know I was paying it all, yeah, and she's like, well, then here's a donation to your, and I give her cash, so I don't know what she did. And say, hey guys, let's talk.
I know, right? At least the fast, cheap, and good matrix.
Yeah.
You can get any two of the three.
Yeah, exactly. But yeah, that was a real adventure going out there and get these things off eBay. And then talking to this guy that sold me the pole, he was out stranded, he's a big surplus guy. And he's all over eBay with those things in different shapes. These things, he paints them white and doubles the price on them. Yeah, a lot of them are a lot more money. You gotta hang out, do the thing that Dennis taught me to do, where you set up a search, and a notification on eBay. It's like military surplus poles, you search it, it comes back, you get a notification every time there's a new posting, and you're like, yep, that's the price I want, that's where I want to go to get it. So that was kind of like I say, an adventure. It was fun. It was weird but fun. So yeah, that's it. The primary thing here is the fan dipole, which I built so I can take any one of the legs off at any time. And yeah, and like I said, I've got a friend who makes these collars for me with a 3D printer. Although a couple guys on the mesh group said that they won't last, and I'm like, no, so far so good. What's
Is that insulator plastic or ceramic? It looks pretty heavy.
this?
No, the white insulator.
It's it's 3D printed. I think he said he used ABS.
Okay, it looked like it was heavy, like
Yeah.
ceramic.
Well, it doesn't weigh a lot. No, it just doesn't weigh anything at all.
Felt like it floated on the table.
No, well, it's probably because of the other hardware I got on there.
Oh,
Yeah. But you get these little clamps you can put on the end of the wires. That's a double, but with here, you can replace these cable ties with singles, and then we literally get the single band antenna for any band, but I don't feel like screwing around with getting the SWR. Of course, every time you go out, the SWR is a little bit different.
Yeah.
All right, how about I do that? Pass the post speaker.
all right. Thanks. Any questions for our presenters?
Make a motion for a happy Thanksgiving. And motion at the holiday party.
All those in favor of having Thanksgiving? Well, we never seconded, but all right. All right, thanks
No,
everyone for.
No, that's seconds at Thanksgiving.
Oh, yeah, second and third.
Oh.
All right.
All
All right, thank you for attending and good night to everyone online.
How many do we have?
I'm not sure, I didn't